Hey everybody, this is Doug with Artfully Rogue, and in this video I'm going to show you how to make a DIY sheet metal brake. Now I put this one on a piece of wood so I can clamp it to a table that I have here in my workshop. As you can see, I'm not here in Arizona, I'm here in Spain. And in Spain I don't have the access to tools like I do in Arizona, so I'm having to make a sheet metal brake to work on a project that I have here. Now this is a welded version, but in this video I'm going to talk to you also about how to do a version of this sheet metal brake that you don't have to weld. You can put together with bolts. So one of the things that I have an issue here in Spain is I'm working with the metric system, and that's just one of a few hurdles, should I say, that I have to face in working in a different country.
Regardless of where I am, I tend to always start my project with a drawing. In this case, I'm using SketchUp. You'll notice here that my measurements are in centimeters. However, I'll put a list of materials in the description with the imperial measurements. Basically, you're going to need 2 pieces of angle iron, 2 pieces of thick flat bar, 2 hinges, 2 bolts with 2 wing nuts, and 2 or 3 pieces of sturdy material for the handles. Here I'm using square steel tubing. The third piece, or the piece in the center, isn't completely necessary, but because I have the ability to weld here, I went ahead and added this support for this particular sheet metal brake. And when you're finished and you have this all together, it will look something like this. Now, as I mentioned, stick around and I'm going to show you a version of this where welding is not necessary. When I do a project, I typically work with the largest pieces first, and in this case, I'm going to cut the 2 pieces of angle iron. And in centimeters, these are 4 centimeters by 4 centimeters, but imperial measurements, these will probably be right around 1.5 inches in both directions. And then with regards to the length, you're looking at 60 centimeters here, and the imperial length is 23.5 inches. In addition to using the metric system, another hurdle that I face here is just getting the material from the store back here to the pergola shop. I don't have my truck here for starters, and the majority of the cars here in Spain and in Europe in general are compact cars. So when I go to Obermatt, which is Spain's version of Home Depot, the shortest length of steel that I could buy for this particular project was 2.5 meters, which is right about 8 feet. Now, as you can see here, 2.5 meters does not fit in a compact car. So you have to get a little creative with picking up material. And once I get parked in the parking garage, I still need to maneuver through.
Okay, steal out of the car, watch the second car, go to the first door, into an entryway, go to the second door, up the set of steps, watch the glass doors and the guy cleaning, take a U-turn, make another U-turn, go to the second set of steps, watch the glass windows, make another U-turn, go up the steps, and into the entryway. Now fumble with the keys so you can get into the entryway, then you can make an immediate right into the kitchen, through the dining room, and onto the terrace, and finally get to the pergola.
Once I get the angle iron cut, I move to the flat bar, and in this case, I'm cutting the first piece to 40 centimeters, which is approximately 15.75 inches. The second piece is cut 35 centimeters, which is approximately 13.75. I'm cutting 45s on each end, and this will allow for room for the wing nut to tighten up the flat bar. You'll see what I'm talking about a little bit later in the video. Despite the few hurdles I'm doing metalwork here in Spain, I'm walking distance to the beach. And right now the weather is amazing compared to Arizona, which is hitting over 100 degrees in the second week of September. Now I've centered the flat bar on top of one of the pieces of angle at approximately 3/4 of an inch from the end. I'm drilling a pilot hole that's going through the flat bar and through the angle. This is going to be the guide that allows you to lift the flat bar to place a piece of sheet metal under. This also allows you to tighten up the bar on top of the sheet metal. And because I don't have a lot of space inside the pergola, I need to be able to move things around. So I'm mounting the sheet metal brake to a beam that I use to frame the floor of the pergola. This way, I can simply clamp the brake to my workbench on an as-needed basis. It's important to note that the angle that's mounted to the beam, it's necessary to remain as flat as possible. So after I drill these holes in the angle, I'm going to countersink these holes so that the screws that attach the brake to the wood don't interfere with the sheet metal that I'm bending. So this is what it looks like with the angle attached to the beam. All screws are flush mounted and will not interfere with the sheet metal that I'm going to bend. Next, you want to clamp the 2 pieces of angle together so that they create a flush surface. And on each end, you're going to be adding a hinge. Now, in my case, I'm using these bullet hinges and I'm welding them in place. But this would be a good time for me to show you how you can do the exact same thing if you don't have access to a welder. Now, as opposed to welding bullet hinges, you can actually use regular door hinges. You simply want to line them up on top of the angle like I just did with the bullet hinge. Drill your holes through the hinge and into the angle, and then tap new threads into the holes so you can thread into the angle. Now, with a handle, I just bolted straight through and use a pair of nuts and bolts. Now, with regards to the top flat bar that I welded in place, you're also going to bolt that. Now here you see the bolts coming up through the angle. That is incorrect, but just to show you the positioning, these bolts are actually going to go through the bottom of your flat bar like this and into your top brace bar. So you're going to drill a hole through the bottom flat bar. That hole should match the holes into your top brace, and then you're going to tap your holes in your brace so that you thread those bolts through the flat bar, if that makes sense. You want to secure the top brace to the flat bar with bolts, and that will give you the support you need if you're unable to weld. And that's how you make this mini brake if you don't have access to a welder. And whether you use the welded version or the bolt-on version, this is the final result that you want to see. You want to be able to lift that outside of angle so that it pivots up nicely. The next thing that I'm cutting here is the tubing for the handle. Now, on these, I'm just using a square tubing that's about 5/8 of an inch square, but you can use round tubing as well. You just want something that's going to be nice and sturdy so when you start to bend the sheet metal, the handle doesn't bend. Now, I'm going to cut little 45s on the corners so that they can properly sit into the angle. If you look at the inside of angle, it doesn't have a perfectly square 90 degree. It has a rounded edge inside corner. Cutting this 45 on the tubing will allow it to sit nicely inside that angle. And just kind of an FYI, throughout this video, you're going to see some movement in the camera. The camera is sitting on a tripod that is also sitting on a flooring that I'm walking on, which has a good deal of movement. That movement is transferring to the camera itself, not to mention that I happen to forget the camera mount that allows me to connect the camera to the tripod back in the US. So it's just kind of hanging on the tripod. Now when attaching the handles, you just want to make sure that they're at a 90 degree. I've moved them in right about 6 inches on each side. That way it's not exactly in the center, but it's also not exactly on the outside when I'm bending the sheet metal. So for this next section, the video was a bit too dark to use. It was getting late in the day and I didn't realize how dark it had gotten for the filming. Basically, the pilot holes I drilled earlier in the flat bar and angle were increased to accommodate a 3/8 bolt. I welded the end of the bolts to the underside of the angle. The flat bar was then able to move up and down on the bolt. I also tack welded the flat bar with the 45s to the longer bar. This will add strength when bending the sheet steel. This is the area that I was talking about where you would bolt through the bottom of the flat bar and into the actual flat bar brace. So this particular bolt and this particular bolt will allow you to move the flat bar up and down. And you can see why now I cut those 45s, because it allows me to easily move those wing nuts up and down. And you see how this goes up and down on the bolts. And because it's flush mounted, this will allow you to put your sheet metal inside the brake and clamp it down nice and strong. Now, whether you realize it or not, I'm actually using a flux core welder. This welding method is super messy, but it's a very inexpensive way to start welding. This is a Yes welder I bought on Amazon for about $175. In my Arizona shop, I use gas welders, but I don't have easy access to gas suppliers here. Flux core welders have a shielded material called flux that surrounds the wire as opposed to gas surrounding the wire. The downside of flux core is that it splatters everywhere. But the weld is just as strong and can look just as good. It just requires a little bit more cleanup afterwards. Okay, now it's time to test the mini brake. I've actually clamped this to a table saw that I bought, which is not the most solid surface to use. However, I don't have a real workbench yet. I'm probably pushing the limits of this mini brake as I'm bending 1 millimeter thick material, which is the equivalent of 18 gauge or 3/64. And the wider the piece, the harder it will be to actually bend. However, this is the size I'll be bending for my sculpture project. And there you have it, a mini sheet metal brake. It's fairly simple to build and even more simple to operate. You just want to make sure that it's on a secured surface, which is going to be my next project, which is making a workbench, or at least buying a workbench that I can clamp this thing to. Thanks a lot for taking the time to watch this video. It is greatly appreciated. Now I'm going to be doing some more content here in Spain. I'm only here for a few months at a time, and then I go back to my Arizona shop where I get back to work doing projects there for clients. My goal here in Spain is to do more sculptural work, and the reason I made this break is I want to build a kind of a replica, for lack of a better word, of a Antoni Gaudí sculpture design of a knight on a horse that kind of looks like this. It's in stone at the Sagrada Familia, but I want to do it in metal to kind of see what that looks like. So it's more of a test project for me here in Spain. We'll see you guys in the next video.